Hey, welcome back, and in this video we're going to start to take a look at how we can start to embed AI into our solutions. And I'm not meaning using the off-the-shelf AI models that you get with all the various cloud platforms. I mean looking at it from a kind of open source perspective. Now normally when somebody talks about AI solutions, it always seems to be about the inner details of how the AI models work, as if you are wanting to become an AI scientist of some sort, and we're not going to look at that from this video's perspective. We're going to focus on how you can start taking some of the best-in-class AI models that have been developed and are available on the internet to be used, how you can get started with them, how you can start to consume them. And of course, in this video, we're going to particularly focus on questioning and answering models. Again, we'll look at the use cases, we'll look at some of the inner details, how they work, etc. But we're going to focus mainly on how you can get started. Alrighty, so to get started, the first thing we're going to do is go and have a look at one of the best-in-class question and answering models that is sort of available for you to use in your solutions today. So to do that, I'm going to open up a browser and I'm going to go to a website called HuggingFace.co. Now, what HuggingFace is they are a company that's trying to build an AI community. So actually, they've got this sort of hub model of AIs that have been pre-trained and are available for you to use. So a lot of companies like Google and Facebook, once they develop a new model that is pretty cool and works for everything and is in best in class, then they essentially give that across to HuggingFace. HuggingFace will do all of the pre-training for you, and then it's available for you to pick up and use in your solutions. So what we're going to do is we're going to explore a couple of the models. We'll look at questioning and answering, and we'll do an example or two, and then we'll look at how you can start to use them. So I've got the HuggingFace website up in front of me. So if I just click on models here, and let me just make this a little bit larger, you can kind of see the you've got lots of different tasks that are available, and we'll cover some of these tasks in different videos. So there's things like text summarization, there's text generation, text classification, the ability to do translation, so from one language to another, like English to French, French to Russian, whatever. But today we're going to focus on question and answering. Now, I'm sure you've seen question and answering type stuff before. So if you've ever used a chatbot and asked a few questions of that, or even if you've used something like Alexa and when you go, hey Alexa, tell me this or that, hey Alexa, tell me who is the quarterback for the New York Giants, then it'll come back with an answer. And underneath that is a sort of concept of questioning and answering. And I'll talk about how that sort of works in a second. So if I just click on the question answering filter here, you're going to see it's going to come back with a list of models that are already in the HuggingFace model hub, which you can use in your own solution. So you see there's this BERT, large uncased whole word masking thing. There's Roberta, and then there's a few other ones, Distill BERT, and then there's Albert. These are all types of models that have been trained and have got various scientific papers behind them, and they're all pretty good, to be honest. We'll probably focus on a couple of the BERT models later on, but again, you can kind of use whichever model seems to work for you. So if I click on this BERT large cased whole word masking fine-tuned model, bit of a mouthful that one, and then you can kind of see the nice thing about HuggingFace has got a little test harness that you can use. So what a question and answering type model always expects is it expects you to give a context. Now what we mean by context is essentially a set of data for you to ask questions against, or a corpus. So if you look at this example here, and I'll just make it a bit larger, it says the context is my name is Wolfgang and I live in Berlin, and then of course I can ask a question. So if you type in where do I live in this case, it's going to come back and it understands that context of text, and then it's smart enough to come back and say, well, I think you live in Berlin based on that text. Now it can get quite complicated. So if I were to, let's just go to something on the internet. So if I go to NFL.com, anyone that knows me knows I'm a big fan of NFL. NFL, and if I click on news, and oh look, there's my team, the New York Giants. So let's click on this article here. There's a whole article about the New York Giants, and it seems to be about the O-line for the New York Giants, and the left tackle is got to protect Daniel Jones. Okay, cool. So if I just take a copy of all of this, I haven't really read too much of that. If I open up text edit for a second, I'm going to copy this into here. I'm just going to make this plain text, and we'll just save that. And then I'm going to copy this article, and I'm going to put it into this context. So now this is basically the article that I've taken off of NFL.com. And you can see it's talking about Daniel Jones, who's the quarterback for the New York Giants. It's talking about the left tackle, Andrew Thomas. If we scroll down a little bit further, it mentions the Giants coach is Joe Judge. So I could probably start asking questions of that. So type of questions I might be able to ask is, who is the quarterback for the New York Giants? And I'd expect that to come back with Daniel Jones. So if we hit compute, give it a second, and there you go. It came back with Daniel Jones. That's actually really cool. So we'll go into the details of how that works for a second, but I want you to just take and hold this for a second, right? I've given this a paragraph of text that I've just randomly pulled off the internet and asked it a few questions, and it's got it spot on correct. So as you can see, it had a 97% confidence factor, so it's feeling pretty confident on that answer. And again, I can ask it other questions. So I can ask it, who is the head coach for the New York Giants? So I would expect that to come back with Joe Judge. So if we hit compute, and indeed it comes back with Joe Judge, and it's got a 95% confidence level. So it's pretty good. That is a really good model. And of course you can kind of check and change some of the other models, but I'm hoping you're starting to get some of those use cases, right? Which is, if you've got some text or some data, so maybe it's a question and answering solution you want to build. So maybe you have a corpus of data, maybe it's a manual, maybe it's an FAQ section. Then, as you could probably see, just grabbing that model and then putting in your data, your corpus of information, and then maybe you might need to do a little bit of fine-tuning, but maybe out of the box it's probably good enough, and then you could open that up to ask questions against it as a kind of chatbot, which is going to be really good for sort of any sort of contact center scenario, knowledge-based type scenario where you want to offer that Q&A functionality. So what we're going to do now is we're going to pull it back a little bit and have a look at what's going on underneath the hood, talk a little bit about what's going on, and then we are going to go and build our own on Google Colab. All right. The first thing I want you to understand is this idea of transfer learning. So what is transfer learning? Well, transfer learning is a new sort of, when I say new, last few years type thing, AI technique that is used by a lot of people. Let's compare how machine learning used to work in the past, right? So let's say you wanted to learn some sort of task. Maybe it was a classification, maybe classify something as a color or pet, a type of dog, whatever, right? Then how it kind of used to work is you would get a set of data, you would label it all up, and then the machine learning algorithm would sort of churn away against that data set. You'll have trained it against that data set, and then it can come back with answers. Now, let's say I wanted to then learn some other classification. Maybe I wanted to learn about cats, or I wanted to classify types of tortoises or something. Well, how you would do that in the past is you would do the exact same thing. You would go and get another set of data with all the tortoises or all the cats or whatever, and then you would train the models again. And these models, these training models, would take quite a long time. It's quite intensive to do that. But if you think about how humans learn, right? We don't throw away all of our knowledge. If I need to learn something new, if I need to identify a cat or a dog or something, I don't throw that information away. I'm building upon my previous knowledge base. So maybe I've learned about cats, and then I will use the techniques that I've used to learn about cats to learn about dogs. I don't go and get a brand new data set and then, wipe my brain and then relearn again. That's not how this works. How everything works is you're building upon previous knowledge. And that's how this idea of transfer learning works as well. So what will happen is you get this general purpose model that has been pre-trained. So in the case of Q&A, the model that sort of powers the underlying Q&A algorithm, the base model, is something called BERT, which stands for Bidirectional Encoder Representation from Transformers. Yeah, it's a real sort of easy thing to remember, right? That'll come off the top of your head. But that BERT model isn't just used for Q&A, it's used for lots and lots of other machine learning or natural language processing routines. So it becomes a base model. And I think BERT in this case is built up of the corpus of data that it's been used to train has been from Wikipedia, and also I think it's a kind of BookCorpus type thing as well. And those two sources of data have been used to train BERT so that it understands the English language or any other language, but it understands the structures of sentences and how to tokenize and all that good stuff, so that it can understand language models. And then once BERT has learned the kind of the core English models, then what you can then do is run a level of fine-tuning over the top. So there's these sort of two statuses. The first status is training, which is training against this sort of large corpus of data, which is the kind of BookCorpus and Wikipedia. And then the second stage is training it against a specific data set so it can learn how to do these fine-tuned tasks. So in this case, question and answer. And we'll sort of delve into that in a second. So if you want to find out a little bit more about BERT, you can just go to github.com, go to Google-research, and then you can look at BERT. So I've got the URL up on the screen just now, and that'll give you a lot more details and allow you to download the papers. The text of BERT, as I said, is I've given you a bit of an explanation, but it's designed to pre-train bidirectional representations from unlabeled text by jointly conditioning on both left and right context and all layers. And as a result, the pre-trained BERT model can be fine-tuned just with one additional output layer to create state-of-the-art models for a wide range of tasks, such as question and answering, which is the one we're doing just now, or language inference, without task-specific architecture modifications. So that's exactly what I just explained a second ago. BERT has been pre-trained against Wikipedia and BookCorpus. That gives it a general understanding of how language works, and then you're then teaching the BERT model how to do specific tasks. Now, if you think about this for a second, right? Downloading Wikipedia is gigs and gigs and gigs worth of data, yeah, huge amount of data. And then it's going to take days and days and days of training on either GPUs or TPUs to get that pre-trained model. And that's where something like HuggingFace comes in, because that pre-trained model is available and you can just download and use that and use it for your own base models. And then you could train BERT to do other language tasks if you want, or in this case, it's question and answering. Now, the second part that's probably important is BERT is unsupervised, right, in its training. So, and if you think about it, that's useful on the internet because there's not a lot of sort of annotated data, but there's loads and loads and loads and loads of articles such as Wikipedia, books, etc. that you can use, and that's kind of how that's been done. Now, the other key thing about this is it's a bidirectional system, and that's what made sort of BERT revolutionary, because prior to BERT, it was sort of a unidirectional type thing. So what do I mean by bidirectional? So if we look at my screen there, you can see that in this example, you see the man went to the mask and he bought a mask of milk. Now, in a unidirectional system, it would have went sort of left to right, and it would have looked at the man went to the whatever it is and then tried to guess whatever was in that sentence. In a bidirectional system such as BERT, it looks left to right and then right to left as well. So it can then guess what's going on there and use the whole sentence or the whole sequence to figure out what these must things are. So in this case, you can look at the milk part at the end, and you can go, okay, he bought it could be a gallon, it could be a liter, but then that makes it kind of easier to figure out that this one here is probably going to be store or shop or something. So that's kind of how that works. And the BERT model, as you can probably guess from that example in the masking, is BERT masks out 15% of the words in the input. So what they do is they take some text, they mask out some of the words. So in that example, it was store and gallon, and then BERT will learn to kind of try and predict what those masked words are. And that's how the training model works until it eventually gets a sort of pre-trained model. So if we look at the official description of BERT, it's exactly what I've just described. BERT has been trained on a large model, so it's 12 to 24 layer transformer on a large corpus of data, in this case Wikipedia and BookCorpus, for a long time, so 1 million update steps, and that's essentially BERT. So that's what we've described. We've got this large pre-trained model, and because it's been pre-trained and because it's been put up on something like HuggingFace, anybody who wants to go and take that model and train their own tasks can do that. So that's BERT. And by the way, if you wanted to, if you were kind of crazy, or you were some sort of researcher or something, you could go and do the exact same thing yourself, right? You could go to something like HuggingFace, and in fact, let's do that. You could go to HuggingFace. So if you look here, there's the Wikipedia dataset, and then you can see there they've pulled the data from dumps.wikimedia.org. So you could go to wikimedia.org, you could download the data, or you could download it from HuggingFace, and then you could train your own BERT model. The other model that you would need if you were retraining BERT for yourself would be BookCorpus, and again, BookCorpus is available on something like HuggingFace. But again, if you wanted to create your own BERT model using something that isn't BookCorpus, but you wanted to use something else, you could. By the way, if you don't know what BookCorpus is, it's essentially, there's a website which has got a large set of free books. So I think there's like tens of thousands of free books that you can download on the internet, and essentially BookCorpus has gone to that website, pulled down those free books, and then brought that together on a data set for training. So that's all really that BERT is. It's just Wikipedia plus books. And if you think books are a good source of understanding language because, you know, it's the written word and there's lots of sentence structure and paragraphs and all that sort of good stuff, so it's a sort of really rich source. But of course, if you've got a different source of data or whatever, you could build your own models. But in all honesty, why would you? Just download one of these pre-trained models and use it, right? Google and Microsoft and Facebook and all that have spent loads of time trying to work out what's the best performing model, so you may as well just use it and then skip to the next part, which is really about creating models that you can use for your own use cases. Alrighty, so where are we on the story? And I promise we're going to get on to coding something in a second. So where we are just now is you've obviously got this BERT model that's really good natural language processing, which is great, and it understands English language. So the second stage of creating a Q&A model is basically you need to fine-tune that English model to be able to answer questions, right? So in the same way as I was asking questions about a bit of text about Daniel Jones and Joe Judge, etc., then you need the model to be able to understand questions. Now, how that works is Stanford have created a thing called Squad 2.0. It used to be Squad 1.1, but Squad 2.0 is the latest set, and that is a data set which has been pre-built with lots of questions and answering, and that is used to basically train your AI model to understand how to answer questions on pieces of text. So if we look at the squad dataset for a second, there's loads of information in there. I could just click on something like Amazon rainforest, and basically how the dataset looks is there's a bit of text here, such as in this case the Amazon rainforest, and then there's a whole bunch of information, encompasses 7,000 square meters, so blah blah blah, loads of information in there. And then what happens is in that data set, there's lots of ground truth answers. So questions have been posed against that data set, and then sort of pre-ground truth answers have been answered as well. So in this case, there's a question, which name is also used to describe the Amazon rainforest in English? And then it's saying the ground truth answer is also known in English as Amazonia or the Amazon jungle. And then lots and lots of questions about that bit of text. In which country can most of the Amazon rainforest be found? And you can see the answer is Brazil. So what's really happening now is we had this model, which was BERT, which was good at English, and now we're training this extra layer. We're doing this fine tuning where you are training that BERT model with an extra layer on a Q&A data set. So basically it is learning how to answer questions, how to interpret bits of text and come back with answers. And again, that squad data set there is got hundreds of thousands, or maybe it's 100,000 type questions. So once you've gone through that training exercise, again, it's going to be pretty good at being able to answer those questions. And that is essentially, if I go back to HuggingFace for a second and we click back on models and go to question and answered, that is essentially what's happening in all of these models. These are models where somebody else has taken natural language processing based models such as BERT or DistilBERT or Albert or Electra. They're all the sort of base models, and then they've trained it against a Q&A data set such as Squad 2.0. And then once all of that training's done, they've taken that model and then they've put that up onto the internet, into this Hugging Face model hub, and then basically you can use that. And the advantage, of course, is you can just use those models and you don't need to go through all the training. So we're becoming the consumers at that point. Now, of course, these models are really designed for general purpose Q&A. If you've got a specialized domain, maybe it's something like computer science or medical, where there's a lot of terminology that is specific to your industry, then you may take something like the BERT model and then train, fine-tune it so that it can understand your industry-specific terms. And again, that's something that you could decide to do, okay? But in general, most of these models are going to be suitable for the sort of tasks that you may want to embed. And again, as you can see, you can just pick them up and start using them in your own solutions. Alrighty, so I promised we were going to write some code. So what we're going to do now is we're going to very quickly take one of these models and start using it online. So what I'm going to do is I'm going to go to Google's Colab, which allows you to essentially do machine learning and run models online, so you don't need to run it on your local machine. It's all free, which is kind of cool. So you can kind of see it. I mean, all it is underneath there is a Jupyter notebook that's been hosted on Google's infrastructure. So if I want, I can just create a new notebook and it'll create one for me. That's kind of cool. And then the next thing I need to do is just click on connect here so that I can get allocated a cluster so that I can run my code against it. And then we can get going. So what I'm going to do is I'm going to use some of the Hugging Face transformer libraries, because I think they've got some pre-built libraries and routines that are pretty cool and gets you going quickly. I'm going to write this in Python today. In a future video, I'm going to show you how you can use this in something like JavaScript and use it with TensorFlow, etc. But for just now, we're just going to do this within the sort of Jupyter notebook type construct, because that's going to allow you to test and train your models and check your models and make sure it's getting the sort of answers you want. And in future, we can basically take those models and run it in microservices, etc. So to get started, let me just hit plus for code. I know I had a code block there already, but I just wanted you to see me type in plus code. To make this work, I need to install the transformers library. So I'm just going to type in pip. And by the way, pip is Python's equivalent of a package manager. So it's like npm if you come from a JavaScript world. And if I just type install transformers, so what that's going to do is essentially download the transformers library for me. So if I just hit that play button there, you're going to see it's going to go off. It's going to go and download that package, install it, etc. And then it'll take a few seconds and it's going to run on that cluster that we set up earlier. So now that that has done its job, I'm going to create another code block. And then what we are going to do is very quickly write our own routine. So the first thing I need to do is just do a from transformers, which is the library we just created. And I'm going to import a thing called pipeline. And that's just a little routine that is used that's been pre-created by HuggingFace, which takes away a bunch of the complexity involved in doing question and answering. So it just makes your life a little bit easier. It's got tokenization, all of that stuff, so that we can focus on creating our models. So now that that's up and running, I'm gonna create a new variable called question answerer. And what I'm going to do is I'm going to create a new pipeline for question answering. And what that basically means is out of the box, HuggingFace has created a pipeline. So basically they've got a pre-trained model that you can use, which I think is based on BERT. And therefore it's already sort of pre-trained so that you can start doing question answering directly. I will show you after this how you can then do something that is a little bit more custom and how you can change the models or use something like TensorFlow. But let's get this working first. So what I'm going to do now is set a context. So if you remember before, we sort of copied and pasted some example of the internet. So it was all about an article about Daniel Jones, but I'm just going to create one very quickly. So the context in this case will be something like Tom Brady is the greatest quarterback of all time, and he plays for the Tampa Bay Buccaneers. I don't think I can spell Buccaneer. He has won 7 Super Bowls. There we go. Fun fact about Tom Brady. So now that we've got a context, we can now start asking questions. So I'll just put a result, and all we're going to do is call my question answerer, and I'm going to put in a question. So in our case, the question will be, who is the greatest quarterback ever? And the context is going to be passed in, so we'll say context is going to be equal to context in this case. That's fine. And then all I'm going to do is print out the answers. So print F, and we'll say answer is going to be, let's say answer, and we're going to have that equal to result. And we want to return answer coming back from this. Okay. I won't worry about the score, etc. We'll look at that later. So if that should be good enough, and if I just hit play there, invalid syntax. Let's have a quick look at how I have messed this up. Yeah, I am such an idiot. Let me just move that to over here, and there we go. Hit play. As you can see, it's going to come back, and then 2 seconds later, it's going to download all of this pipeline stuff, and then it's going to run it. And we should now have it coming back saying Tom Brady is the greatest quarterback ever. And again, we can ask other questions, so we can just write something like, what team does Tom Brady play for? And then if I hit play again, we should get Tampa Bay Buccaneers coming back. So again, it'll take a second, and again, it comes back with Tampa Bay Buccaneers. So that's how that works, and you can get off and start using that straight away. So I've shown you how that works using the kind of inbuilt pipeline libraries that come with transformers from Hugging Face. But actually, what I'm going to show you now is how you can code a little bit of this yourself, use TensorFlow, and allow you to change some of the models underneath there, which of course, this is going to be super useful in later videos when we take those models and then run them directly in TensorFlow and embed them as part of your microservices. So rather than you watching me sort of type all of this out, I'm going to open up one of the previous notebooks that I've created just for a little bit of easiness sake. So I'm just going to install transformers again. So this case, I've pre-created this one where we're going to use TensorFlow and not use the pipelines library. Again, pipelines library makes things super quick and takes away a bunch of the complexity, but of course you can use this if you need to do something like changing the underlying model. So if we look at the thing that I've set up, so we've opened up we've imported some tokenizers and a model for question answering. We've imported TensorFlow, and then what we're going to do is kind of load up the models that we're going to use. So you can kind of see there that I'm loading up BERT, large uncase whole word masking, fine choose squad. And if you were kind of remembering what we did earlier, you can see that's just the name of the model that we've got from here from Hugging Face. If I wanted to, I could just put in any other model. Like I could use the Distill BERT base case Distill squad there, which is sort of trained on Distill BERT and trained on squad 2.0, and I could use that in the model if I wanted to. In fact, we'll demonstrate in that in a second. So if I took that, and then I can set the context. I preset a context there already, but what we're going to do is we're just going to put in the same context as we had earlier. And then I've got a few questions that I've sort of pre-created. So why don't we just put in sort of same sort of questions that we had before. So we'll ask who is the greatest quarterback of all time. No, just who's the greatest quarterback will do, and then we'll maybe ask a question on who does Tom Brady play for? Yep, so 2 questions there, and then what you can kind of see, it's just going to loop through those questions. It's going to make a call to TensorFlow, and then come back with the answer there. So if I was just to run that a second, it'll take a few seconds because it's going to download that model again. But once it's done that, then it will come back with an answer. Okay, as you can see, the model's run, and then it's come back with the answers that we'd expect. It came back with Tom Brady is the greatest quarterback of all time, as you would imagine, and it's correctly figured out that Tampa Bay Buccaneers is who Tom Brady plays for. And again, as I said before, if I wanted to change the model, then I could. So if I went into Hugging Face again, and then I just picked a model that I wanted to use, so maybe I'll use this Distill BERT uncase model. I could just copy that in here, and then all I need to do is just change the model that I want to use for tokenization and the model I want to use for question and answering, and then I can hit the play button again, and then it'll download that model, and I can use a different model completely, and then it's going to come back with the answers. Why that's important is different models are going to be better at different tasks, so it's worth playing around as you build up your own corpus of data and your own questions and answers, and then see which model works best for you. And of course, maybe you're going to fine-tune a model for yourself, but as I said, most of the models here is probably going to do the job for what you need. So as you can kind of see now, it's downloaded this different model, and then it's worked, right? It's came back with Tom Brady and Tampa Bay Buccaneers. So one of the reasons you may want to use a different model is some of these models can be quite large, and if you're just going to answer simple questions, you can maybe use a smaller model, which is going to be just as good as answering the question for you. Okay, so just to kind of summarize, I've shown you what Hugging Face is. We've talked about what Transfer Learning is. I've shown you how these pre-trained models are built and how you can access them from Hugging Face. And of course, course, you can just pull them and use them. And then at the end here, we've used Google Colab to basically go and sort of test out our models and load data and context so that we can use question and answering. So I think that's a pretty useful technique. I'm not seeing many people using question and answering and AI models as much as they could be using in their solution, but hopefully you can see that it's pretty easy. Now, in the future, we're going to be able to take some of these TensorFlow models that we've created and we'll be able to embed them with our microservices, and I'll show you how to do that. And of course, in future videos, we'll look at other types of AI models such as text classification, etc. And we'll also look at how you can build up your own corpuses of information, because we've used very small bits of text, but if you think of something like Alexa or Google, for example, they've got data that is huge corpuses of information, and we'll show you in future videos how you can build up your own corpuses so you can come back those answers. And then I think one of my other future videos, I'm going to show you how you can actually take data that you've got already in a different form, translate it into English, and then be able to ask questions against it. And I think that's a pretty exciting use case. Anyway, I hope this video has been useful, and I'll catch you on our next one. Speak soon.